In this video, we're going to talk about the file types for digital audio and a little bit about the idea of perceptual coding. So we have three broad categories of file types. There are full resolution files. These are files that contain all of the information. So the file will be the same size regardless of what's in it. If it's silence or the loudest thing you could possibly imagine, if it's a WAV file, that file for the same length of time will be the same size. There are lossless compression files, which lossless compression makes the file smaller by using compression ideas that let us get the same thing out at the end. But the file's smaller in the middle. It stores it with less space. And then lossy compression is a way of making the file smaller while actually discarding some of the data. So the math used to make full resolution files is called pulse code modulation, or PCM. So sometimes you'll hear the term PCM if they say the PCM file. That's what they mean, or a full resolution file. The two most common file types of PCM files are WAV and AIF. Pretty much everything's on WAV now. AIF was the native PCM file on Macintosh operating systems back when they ran on PowerPC chips. The difference essentially has to do with the direction of the bits. If it starts with the most significant bit or the least significant bit, you don't really need to know all that because now the stuff is fast enough that you can use AIF files or WAV files on your Mac or Windows machine. But everything is pretty much WAV file now. So when we talk, if I ask you to turn in a PCM, I'm asking you for a WAV file. But that's a little bit of the history. And if you run into something that's AIF files, it's okay. That's what that means. Lossless compression is a type of file compression that makes the file smaller in such a way that we get the same information out at the end that we put in at the beginning. In audio, the most common lossless compression file type is called FLAC, which stands for Free Lossless Audio Codec. There's also Apple lossless files and Windows Media lossless files, and there's some other things, but FLAC is pretty much the common one. And a way to talk about how to understand this, and I'm not going to give you the nitty-gritty inside math on every file type because I don't fully understand it myself, but the idea is we're storing the data in a way that doesn't ask us to store every sample completely. So think maybe there's a mechanism where you record the first sample and then you record, okay, the next sample is 10 higher and the next sample is 100 lower, etc. And then at some interval you record other samples to sort of double check. So instead of recording every sample, you're recording samples and differences. Or if you think about it in a visual representation, a large portion of this slide is just white. So instead of recording 16 bits worth of color or 8 bits worth of color, whatever it is, for every white pixel on the slide, it might say, okay, all of these pixels in this area are all the same. So you get the same thing out at the end, but you haven't stored the same amount of data, if that makes sense. So that's sort of how some of these lossless compression algorithms work. And you can get almost half the file size often out of a lossless compression algorithm. Lossy compression discards some data. So these are things like MP3s or AAC, which stands for Advanced Audio Coding. It's usually the extension is M4A. Or ogvorbis.ogg, which is what Spotify uses. These are all lossy compression formats. And they do the math a little differently, each of them. But essentially, you can get to about 1/10 of the file size in something that we might think sounds okay. Between 1/10 and half the file size sounds, if we get lower than 1/10 the file size, the original file size, probably sounds bad anyway. And the assignment for this week, you'll do some experiments with this and get to make some of your own judgments. The way these lossy compression encoders work is they use perceptual coding to decrease the file size. The idea behind this is that Essentially, it tries to decide what you won't miss. So if I do this by the microphone, you can hear my hands making that noise probably. But when I talk, it probably gets a little softer because it's being masked by my voice. If I did something that really masked this, like shh, it completely gets wiped out. So the idea that when things share frequency space and time space, so when they're in a similar frequency range and happen at similar times, certain sounds will mask other sounds. So that's one of the basic ideas behind how lossy algorithms or lossy codecs make things smaller. It's largely about the idea of masking. Neither of these types of masking are actually what we're talking about. It's more about audio masking. And in the video around the assignment, I'll give you some different files to convert to different things, and you'll get to listen to them and look at their sizes and get a little bit better understanding of that.